Hello. In this video, we'll demonstrate 5 different login methods for SES, SecureDoc Enterprise Server, including one we refer to as the Secure Internet, due to its implications for protocol-level authentication and trust. SES is a SaaS-based management console used to administer endpoint disk encryption and secure online access across user, devices, and service providers. The first method is the usual mobile app that receives a secure push notification over the network. To complete the login, the user enters a number displayed on their MagicEndpoint mobile app. The second method is more secure, using a FIDO passkey securely stored on the user's mobile device. When a login is initiated, the server performs a FIDO2 authentication with the endpoint. The endpoint then connects to the MagicEndpoint mobile app over Bluetooth Low Energy (BLE), establishing proximity. The user verifies their identity through biometric authentication on the phone, and the mobile device uses its stored key to complete the FIDO2 protocol. The third method uses a FIDO passkey secured by the device's Trusted Platform Module (TPM). No mobile device is required. Authentication is performed directly on the endpoint, allowing deeper inspection of device trust signals. The login process is completed with a single click, with no additional user interaction beyond endpoint presence and integrity verification. In Method 4, the endpoint maintains a persistent connection to the MagicEndpoint Identity Provider (IdP), delivering event-driven, real-time updates about user presence, device posture, and geolocation. This connection functions as a trusted channel, similar to the phone number printed on the back of a bank card, always available for verification. With continuous trust signals, the IdP can confidently grant access to the authentic user and device without requiring any user interaction. The fifth method uses mutual TLS, MTLS, with MagicEndpoint. MagicEndpoint generates a live key that asserts the presence of an authentic user on a trusted endpoint, with organizational security policies satisfied. This live key is used to establish MTLS with the server, allowing the browser to authenticate both the user and device directly at the transport layer. The user never sees a MagicEndpoint IDP login prompt or any authentication screen, because the entire process is fully transparent. This method provides strong protection for all transactions and is inherently resistant to session token hijacking, with zero user interaction required. All 5 login methods can be used to authenticate to both the service provider (SP) and the identity provider (IDP). However, supporting complex methods like FIDO2 can be challenging for SPs. Since TLS is widely supported, MTLS-based authentication can be implemented with less development effort. In this model, federated authentication and the IDP become optional. The IDP can instead act as a real-time trust evaluator, invoked only when additional verification or context is required. You'll notice that methods 4 and 5 require no user interaction. Method 5, in particular, uses mutual TLS, MTLS, enabling authentication at the transport layer, securely binding user and device identity without additional steps. The user never sees a MagicEndpoint IDP login prompt or any authentication screen whatsoever. The entire process is completely invisible. This approach forms the basis of the Secure Internet, a proposal we recently submitted to IETF and W3C. But adoption may take time. Today, MagicEndpoint supports zero user action login through continuous verification over a persistent, trusted channel, providing strong protection for workforce access. This level of security and usability can be achieved with or without integrating MagicEndpoint's disk encryption or Windows login components, which support a broad range of multi-factor authentication (MFA) methods, including pre-boot authentication, TPM PIN, smart cards, mobile proximity, and more.